Welcome to the Deep Dive. This is where you bring us the complex stuff. White papers, research, you name it, and we dive in.
Yep, our job is to take that dense information and really unpack it, find the core insights, and make it clear and hopefully useful for you.
And today, we've got a source that definitely feels futuristic. It's a white paper talking about a quantum blockchain.
Quantum blockchain. That certainly catches the ear.
It does, and you probably know the usual issues with classical blockchains, right? The massive energy use, scalability problems, the whole quantum computing threat hanging over them, transaction delays, centralization risks.
Absolutely. The paper highlights those right up front. These are real roadblocks. But what's interesting here, the hook, is that this system isn't just proposing a minor tweak. No, it claims to completely rethink how a distributed ledger works. It wants to base the whole trust mechanism on, well, the laws of physics.
The laws of physics, as the validator. That sounds ambitious. The paper suggests this allows for things like absolute validation, unbreakable security, true instant finality, things we don't really get now.
Exactly. Things that seemed maybe impossible for decentralized systems before. So yeah, let's dive into how they actually propose to pull this off.
Okay, so what's the core idea? You mentioned it's not like proof of work or stake.
Right. The paper introduces this concept called Proof-of-Coherence, or PoCoh, and they're very explicit. This isn't just an iteration. It's a totally different architecture for building and validating the ledger.
Proof-of-Coherence.
Yeah.
And it's based on quantum mechanics.
Directly. That's the foundational layer. And if you look at what they claim in the executive summary, the benefits sound pretty extraordinary because of that physics base.
Like what specifically?
Well, things like 100% classical runtime operation, meaning your average node doesn't need to be a quantum computer day to day.
Yeah.
Microsecond validation speed.
Microsecond. That's incredibly fast compared to what we're used to.
It really is. Plus, zero mining overhead, no need for staking assets, and it's apparently free from dependencies on specific on-chain hardware for the actual validation process.
Okay, that list sounds almost too good to be true. How does quantum mechanics actually make that possible? What are the principles involved?
That paper mentions a few key quantum concepts that PoCoh relies on. There's quantum superposition, a particle being in multiple states at once.
Yeah.
And quantum entanglement. That's the really weird one. Linked particles influencing each other instantly, regardless of distance. The spooky action, as Einstein called it.
Right, I've heard of that.
And crucially, they mention Bell-type inequalities and the CHSH framework. These aren't just theories, they're ways to experimentally prove that these quantum correlations are real and, importantly, stronger than anything classical physics can explain. That experimental proof part is vital here.
Okay, so entanglement is provably non-classical. What else?
Then there's wave function collapse. When you measure a quantum system, it snaps into one definite state, and that process is irreversible. You can't undo the measurement perfectly.
Irreversible. That sounds important for security, maybe.
Absolutely. It's like a unique event marker. They also talk about quantum coherence and visibility. Coherence is about maintaining those fragile quantum relationships. Visibility is how you measure that in their system. It has to cross a specific threshold, Beeman, which they state is 2.4.
2.4. Where does that number come from?
It's related to Zarielson's bound in physics. It basically sets a limit for classical correlations in these types of experiments. If your measurement exceeds 2.4, you've demonstrated something genuinely quantum, something classical physics can't reproduce.
So the check is literally, does this signal look quantum enough based on a known physics boundary?
Essentially, yes. Is the quantum signal strong and clear? And finally, the no cloning theorem. This is fundamental. You simply cannot make a perfect copy of an unknown quantum state. Physics forbids it.
Okay, so entanglement, collapse, coherence thresholds, no cloning. Quite a toolkit from quantum physics. But how do these things actually validate a block? That's the leap I'm trying to make, this proof of coherence.
Right. This is where it gets really different. The core mechanism involves a unique signature, they call it sigma, in each block header.
Okay, like a digital signature.
Sort of, but its origin is completely different. This sigma doesn't come from solving a math puzzle or from validators voting with their stake. It originates from a single high-visibility Bell or CHSH quantum experiment. Something performed once during an initial quantum native setup phase for the system.
So each signature is born from a unique quantum measurement event, not computation.
Exactly. Now here's the validation part, and this is key. Every node on the network could be a big server, could be a tiny Raspberry Pi, doesn't matter, performs a check that is purely local and deterministic.
Local. meaning it doesn't need to talk to other nodes to validate that specific block.
Correct. Not for validating the block itself. The node just runs a function using the signature from the header. It's instantaneous.
And what does this function f actually do?
It tests if the quantum correlation encoded in that signature, sigma, is strong enough to violate those classical physics limits we talked about. Specifically, the paper says it checks if the signature's Bell score is higher than that B-min threshold of 2.4.
So the check isn't, did enough miners work on this? Or did enough stake vote yes? It's literally, does this signature contain evidence of a quantum effect that classical physics cannot explain?
You've got it. It's like the signature carries an unforgeable quantum watermark, and the function f is just a straightforward physics test on that watermark. The result is binary. Yes, this is valid because it shows the right quantum properties, or no, it's not. It's derived directly from physics encoded in math.
Wow, okay, that's fundamentally different.
It is, and that's why they claim you get instant finality for that block, and why you don't need mining or staking or network consensus rounds just to confirm if one block is valid according to the rules.
The trust isn't in the network majority, it's in the physics itself. That's a huge shift. What does that imply for security then? You know what? Let's explore that further, right after this quick word from our sponsors.
For peace of mind, get PoCoh.